Hello, this is Dr. Anderson, and I'm going to talk to you briefly about Chapter 2 of our textbook, which is Norms and Basic Statistics for Testing. So, why do we have to have statistics involved in testing? Well, in the social sciences, we are not measuring and dealing with absolute values that are intuitively meaningful. In the physical sciences, we have such measures. For example, weight or length. It's pretty easy to understand units of measurement in length and weight. If something measures 12 inches, well, we know what that is exactly. If one object measures 12 inches and another measures 24 inches, we know right away that the second object is twice as long as the first object. So the meaning of the units is abundantly clear. If something weighs 0 ounces, that means it has no weight, it doesn't weigh anything. So again, all of these physical measures, the ones that we're familiar with from everyday life, are pretty self-explanatory. However, in the social sciences, we're trying to measure abstract constructs, such as the presence of a psychological disorder or an abstract trait, such as self-confidence or empathy, or intelligence, which is abstract. And so there's no absolute way to measure this. There's no absolute unit that we can resort to that we all easily understand. So basically, what we need in order to measure and then communicate our measurement is some kind of criteria about what the units are and what they mean. And that's where norms come in. Norms are the criteria that we use to understand the value of the scores. So how do we get norms? Well, that's where the statistics come in. Basically, in order to get norms, you have to administer the test to a group of people, and hopefully this group would be large and it would be representative of the subjects or people for whom you're designing the test. So if you're designing a test to measure self-confidence in women, you'd want to administer it to obviously a group of women. And you might want to have women of all different ages and different ethnicities with different levels of education so that the test could be used for all of those different kinds of individuals. You'd also want to have a large group because you have less measurement error when you test with a larger group. You're more likely to make an error and find something erroneous if you're dealing with a very small group. So a simple example is a poll. If you want to try and predict who's going to win the next presidential elections, what would be more reliable? Polling 5 people or 5,000? Right away, you know it's going to be 5,000 people. So it's the same with psychological measures. The larger your sample is, the more representative it is, the less error there's going to be. So once you administer the test, whatever the test is, test of intelligence, test of depressive symptoms, whatever it is, once you administer it to a large group of people, then you use statistics to try and decide, okay, what is the meaning of different scores on this test? What constitutes average? What constitutes superior performance? What constitutes significant in any respect? For example, on a depression scale, how many points do you need before we say, yep, this person's depressed? So when you have your large group of subjects, what you're going to do is administer the test to them, and then you're going to compile statistics to help you to make meaning out of the scores. Imagine for a second that you receive a test or a paper back from a professor, and it has a grade of 72 on it. Well, that number by itself doesn't mean very much. It would be helpful to have some criteria from the professors to, for example, what would constitute a passing grade, or what would constitute an A grade or a B grade. That would begin to help you to make sense of the 72. Otherwise, it's just a number, and you don't know if it's good or not. Another way to make sense of your test grade, besides classifications that are set by the test administrator, in this case your professor, would be how did the other people do relative to you on the test. So the way you interpret a B grade of again, let's imagine 72, would be different if you knew that the average grade on the test was a B versus if it was a really hard test and the average grade was a C minus and half the class failed the test. So the significance of your 72 would be different depending on how the rest of the class did. This, in essence, is norms. Norms mean that we look at the performance of a representative group, and based on how they perform, we calculate if our own performance is average, below average, above average, problematic, significant, etc. So it's just a way to do that with numbers. The easiest and most easily thought of example of this is averages. Imagine a test of compassion where the average score is 80. Knowing the average would help you to begin to understand a score of, say, 88. By itself, the average doesn't tell you everything you need to know to make sense of a score. For example, in this case, we know 88 is above the average, but how much above the average? Is it still kind of average, or is it in the above average or superior category? The only way to know that is to have some sense of what the whole range of scores or dispersion of scores is. So, if the lowest score on the test of compassion was 40, that's the lowest any subject scored, and the highest is 120, then a score of 89 still seems about average, doesn't it? But on the other hand, what if scores only ranged from 70 to 90? The average was 80 and the lowest score was 70, the highest was 90. Then all of a sudden the score of 89 is pretty high, isn't it? So it's not enough to have the mean, you also need some measure of dispersion. And in social sciences, the primary measure of dispersion is the standard deviation. The standard deviation is a standardized way to measure variability of scores around a mean. In your textbook, you have figure 2.8, which shows you the normal curve, and it's a nice pictorial representation of what standard deviations mean in real life. It also gives you, I believe, percentiles, which is another way that we can make meaning out of tests. If we were to give a test to a group of 100 people, we could rank them from lowest score being a percentile rank of 1 to highest score being a percentile rank of 100. Then, with subsequent subjects, we could convert their scores into percentiles or percentile ranks, and that would tell us where they fell in the distribution. If someone received a percentile rank of 98, we can see from this diagram, figure 2.8, that they would be in the top 2% of the population. So percentiles, means, and standard deviations are essentially a way to make meaning out of what's essentially pretty arbitrary numbers, unlike in the physical sciences where some of our measurement has intrinsically meaningful units which are understandable to everyone. We have to construct that for ourselves in the sciences such as psychology and sociology. Okay, so I'm also asking you to read chapter 3 this week, and all you need to know about there is correlation, what it is, what it means conceptually, and then how it's reported. If you've already taken the research class, then this will be a pretty easy review. If you haven't, then you might want to do a little additional reading, maybe from another textbook of a similar kind, just to get the hang of what a correlation is, what a correlation coefficient is, and what it means, because that's going to be important to ideas such as reliability and validity, which we will be covering in the weeks to come. Chapter 7 is pretty easy reading, and the essential concept there is that it's really important how a test is administered. If you administer a test to one person one way, to another person in a different setting or in a different way, then those two scores are not really comparable. Ideally, the test should be administered in the same way to everybody, and the test should have been administered in the same way to the normative group or the normative sample on which the norms were developed. Norms being, of course, at this point, you know, means, standard deviations, classifications, percentiles, etc. So happy reading. Please contact me with any questions. I know this material is really dense. We'll be going through some dense material for a couple of weeks, and then the readings will be lighter and more conceptually oriented. Good luck, and I'm available to answer any questions you may have.